So to find the nucleus, we need to define dsx, which is equal to v of s, minus summation of x, xi, I from in S. So basically this is a deficit or complaint of the coalition. Oops. So instead of guessing and verifying in this problem, we can just, at least I will try to formally write down all these numbers. So here the important thing is though, is like how many sets we need to consider. Well, that is going to increase with the number of players obviously, but here it's a bit more manageable. So the set S can be A alone, B alone, C alone, AB obviously, AC, BC, and the grand coalition ABC. Okay? Well, we don't look at the empty coalition because, it doesn't, well, the definition, does it say anything about it? Let me check. It doesn't, but it doesn't make any sense of looking at an empty coalition. So look at non-empty coalitions. Well, here, remember A gets small a, this is what B gets, this is what C gets, this is A plus B, this is A plus C, this is B plus C, and this is A plus B plus C, which we know that it's equal to 1, by the way, by feasibility. Okay, and these are all positive, we know that as well. So here, when I calculate dsx, it basically V of A minus small a. What is V of A is 0. So it's a 0 minus A, so it's minus A for this one, okay? Comma, I said equal, I'm abusing the notation a little bit, I'm sorry for this. So what is D of BX, I'm sorry. Well, it's VB minus B, so it's again 0 minus B, so minus B. Same here, minus C, this guy. And here, V of AB is 1, so it's 1 minus A minus B. Here it is going to be 1 minus A minus C. Here it is going to be 1 minus B minus C. And here it is going to be 0. Again, use the efficiency of feasibility, remember 1 minus A minus B is equal to C. This is what? B. This is A. And this is 0, minus C, minus B, minus A. Okay, so what? Well, if you remember the weird part of, intuitively I think nucleus is beautiful, but calculation is, to be honest, pretty, not so easy, let's say it that way. So what do? We create a vector, right? And this vector, do we have a specific node? Well, I don't know how to call it. Well, let's call it X. So this vector is going to put the larger numbers first and then smaller numbers. But obviously, I can't know which one of those is larger without knowing a specific x vector, right? For example, if x is equal to 1/3, 1/3, 1/3, okay? Well, then I know that these three guys are 1/3, 1/3, 1/3. These are minus 1/3, 1/3, 1/3, and 0. So therefore, this x would be written as, let's denote it by x head in order to differentiate the notation. It would be 1/3, 1/3, 1/3, 0, minus 1/3, minus 1/3, minus 1/3. So this 1/3, does it correspond to this one, this one, this one? Doesn't matter, okay? Because they all are the same. It really doesn't matter which one you put first. However, if my x, or let's call it y, is 1, 0, 0, well then it would be what? So this is 1. So my y hat is this. 1, I put the highest, remember, first. And then what about the others? These are 0, right? So I have, and these are also 0. So I have like a lot of zeros. I don't know how many, 6, 7 total. So 3, 6. And I should have minus 1 here. Yep, that's it. So this is what y hat would be. So then a nucleus, for example, x is a nucleus if x is strictly higher than all the y's, such y's that you can create, according to lexicographic preference relation. Remember this definition that we defined in microtheory? You basically compare the first numbers first in these two vectors. So for example, here y hat is definitely higher, but here we have the inverse lexicographic kind of, meaning the smaller number is better. So when we compare the complaint, so this is like if we distribute the surplus according to y versus according to x, this is, you know, how much complaint we're going to get. In y, we're going to get a huge complaint from one of the players, which is coalition BC, all right? And then no complaints from many others, kind of, I mean, let's call it no complaint. And then one guy is super happy, obviously this is agent A. And here, however, the complaint is going to be 1/3, 1/3, 1/3. So it's a huge, the bigger complaints are bad. So therefore, we choose the vector which has a less and less complaint. So here, clearly, I'm sorry. If you do this lexicographic comparison, x hat is better than y hat because its complaint, its highest complaint is less than highest complaint of y hat. All right? But the question is, we should have this for any y hat that you can generate. And there are infinitely many y hats you can generate. Just choose different y. So, then how am I going to find the nucleus? I mean, is it easy? I think we can still prove that this is the nucleus. I mean, this one, I'm sorry. How do we prove that? Well, I'm just, because of the time limits, I'm just going to do it informally. But here's how we would do. If you want to find some vector y hat where the highest complaint is less than 1/3, okay? So remember, the highest complaints are coming from these three coalitions, okay? So therefore, you have to make one of those guys less than 1/3. Agree? So either A or B or C must be less than 1/3. So let's say A less than 1/3, less than or equal to. Well, what about B and C? Well, if B and C are also more than 1/3 in this case, well, remember, we are putting the highest complaint first. So I cannot have B greater than 1/3, but A less than 1/3, because B and A will switch their places. And so y hat is going to become worse than x hat. So therefore, this is not just enough. I also need B less than 1/3, but same for C. C also must be less than, because otherwise, if A and B are less than 1/3, but C is greater than 1/3, well, the first component is going to become C,